there. So yeah, welcome for anyone who's new here today. Tech20. It's done in 3 parts. So the first part, you just have your lunch. We'll have a 20-minute discussion presentation, and then we'll have 20 minutes for questions. I will introduce our speakers today. So today we are joined by Steve Coates of Brainwave. And I'm also going to be joined by Steve Ashley of the Digital Transformation Solution Center. Just a couple of questions then. Steve, can you tell us a bit about yourself and a bit about what you're going to be presenting today?
Good afternoon, everyone. So Steve Coates in the green zone. Something about myself that most people don't know, I dropped out of school at the age of 16 and trained as a chef for 4 years and ultimately head up a data science company. So you heard it here first.
And Stephen, I'm wondering if you could just tell us how this aligns with the work that we do here in the digital transformation team.
Yeah, thanks, Blair. Thanks, everyone, for coming. So yeah, we're really interested in AI and data science and how that can help transform the oil and gas industry. And we're also, as part of our mission here at OGCC, not just looking at new technology that will help the UKCS in terms of its, maximizing or optimizing our resources, but we're also looking at how we support the supply chain. So Steve and his company are using data science in a rather interesting way, and I think you're going to hear a little bit about that in various contexts. But we see this as a technology that could be used by the supply chain to understand their market, not only here in the UK, but actually globally. So it's one of the reasons we're talking to Steve, and I'm sure he can tell you more about it. So welcome, and over to Steve.
Thanks, Stephen. So last month, I saw something that really blew me away. I took my kids to Dynamic Earth in Edinburgh. I don't know if any of you have had the chance to be there. And they have this population counter. So this is the world's population growing as we speak now. Now, what really surprised me is 20 years ago, I used to work at Dynamic Earth when I was a student at Edinburgh University. And that number started with a 6. Okay? It gets a bit more frightening than that. By 2050, that number is almost going to start with a 10. So it's no surprise the world's population is growing at a rather alarming rate. In addition, a third more of those will live in urban environments in cities. And if you couple that with this idea of a net zero future, we're going to be reducing our carbon by a third. So that's one hell of a challenge to the people in the world, and actually to the people in this room who are very closely connected to this future. I've only got 20 minutes today, so I can't tell you all the answers on how to solve that challenge. But I did want to share with you some thoughts around how artificial intelligence, data science, data analytics can perhaps help companies in the oil and gas sector on this journey towards a net zero. Now, if you simplify down what data and data analytics can do for you, my interpretation of that is it's really helping you understand the what, the where, the when, and the how. So first off, you can collect data together and it can tell you what's out there. So if I'm thinking in a business development context, new markets, you can pull your data together and you can understand what projects, what assets, what opportunities are there. The other thing it can do for you is it can understand where these things are. And often a picture is much better than a spreadsheet or a slide. It's about clustering these things around your existing operations and understanding how they fit in with your existing business plans. Then you can understand the when. So knowing when these projects start on different timelines and how they fit in with the bidding cycles is obviously key if you're going to be bidding for that work. And then finally, the how. So this is one of our graph databases, which is really pulling together all of this knowledge and helping you understand how do those things connect. So what networks exist within those data sets and how do you pull them into your own advantage. Okay? This is actually a really interesting area for me. We took it one stage further, and I think it's on this one. If I can get the clicker to work. I've gone too far forward. This one. So what we did is we took all of the power assets in the world and we turned them into a graph database. And it resulted in something like 1 million different nodes. So in graph databasing, the dots are nodes. So think of them as things like names, places, people, assets. And the vertices are doing things. So this person works at this company, or this asset belongs to this company. The graph itself is far too big, even on a screen this size, to show. But what you can do is when you have the data in that format, you can run data science algorithms on it. And you know, the algorithm that we've run on this is called a community analysis algorithm. So what it's done, it's gone into those 1 million nodes and 4 million vertices, and it's trying to find patterns of how these things are connected. And so the different colors represent different communities, where the greens are all linked and the blues and the pinks. Now, apart from that looking like a nice, pretty picture of a firework, that can be quite useful when you're thinking about new market entry strategies, about where these opportunities lie and how you create shortest paths between these different assets, people, contracts, so forth. Now at Brainwave, and well, not just at Brainwave, any of these companies, it all starts with the data. So I think, what's different today, why the change, why do we see this rise of AI and data science driven companies coming into the sector? Technology exists now where you can combine these data sets in a way that you can make use of. That's a non-trivial task. So these are just some of the data sets that are in our platform. And to give you an example, Bloomberg will charge you on per view of the data. So every time somebody logs in and they look at a Bloomberg data stream, it's charged, it's on cents on the dollar, so you need APIs that can track those charging mechanisms. Other companies like S&P will have batch downloads of their data sets. S&L have per user licenses, so if you have a platform that's been used by a large company, you need to be able to track the users. So there is a degree of complexity in that, but technology does exist today, and well, we've created some technology that can help you pull all of those things together and merge them into a single source of truth. So when you think about data science, the algorithms that enable you to manage and wrangle those data sets, I think when we first put our version 1 platform together, in mining, I think there was something like 400,000 mines worldwide. Actually, there's only 57,338 mines. So there was a lot of overlap, a lot of duplication. But algorithms that look at geospatial, where are these things located, who owns the assets, text analysis based on the names, is it BP, is it BP PLC in your world? You can simplify that data set into a single source of truth. What I want to do now is share with you 2 examples, and actually, well, 3 if the time allows me, but it might just be 2, of how we're using more advanced data sets and data analytics to change the way that a company looks at business development and how it attracts business. So the first of these is with some satellite data. I'm not sure if anyone's heard of the VERS satellite. It's a NOAA satellite out of the US. And it's orbiting our planet, and it takes a nighttime satellite image every night. So we've got a live data feed from this satellite that comes into the platform. And what's interesting is you can identify gas flaring. So all of these orange blobs on this map, I don't know if you can see them at the back, they're, I was going to say last night's data feed, but I sent the presentation in on Wednesday, so they're Tuesday night's gas flares. And there's quite a bit of sophisticated data science behind that in terms of taking a satellite feed and identifying radiant heat sources, and then stripping out those that are bushfires and forest fires and various other things to identify just those flares. But you can actually take that one step further and you can start looking at the assets that are located. Now, obviously, it's not going to be an exact match because these assets are reported by companies and organizations, and we were just talking about what three words, and the postcode will be off slightly compared to a satellite image. But you can see there's a pretty good correlation. And once you're able to tie things back to assets, you can then take it to the next stage, and you can start tying it back to companies. So this is Nigeria. This is 2018. And this is, well, I won't go into the company names, but you can all read them from there. So why is this important? So the reason that we started doing this was actually not for the net zero journey, but for one of our customers, a company called Agreco, who sell mobile power generation units. So these big ship containers that they ship, and they power things like the Olympics and Super Bowl, and also oil and gas platforms and mines. And they developed a new product which was specifically tailored for gas flare, for the rich gas that's in a gas flare. And so for their business development people, having the ability to look on a daily basis where the flaring is happening, tying it to an asset, as you do here, and then actually you can click on that asset and use scraping algorithms to find all of the people that are connected to that asset. And then you can feed all of those people straight into your Salesforce CRM or your Dynamics CRM. So what you've done is you've taken data from space, and with a few clicks of the button, turned it into an actionable business development process where people can target the flares that have the highest volumes or the locations that they're going for. Turns out there's a pretty good correlation. So we have back-tested the algorithms with official figures. This is in Nigeria again. So it's a pretty good piece of science that people are using, and I think we're just touching the tip of the iceberg. I know that we're talking to OGTC about how this could potentially be used to monitor it on a global scale, or even in the North Sea. There is precedence in I think it was Norway, when they put a focus on gas flaring. Within 4 years, I think they virtually eradicated it from the platform. So that's an interesting way forward. Okay, change pace a bit, slightly different example. And this is actually some work that we've been doing and are doing with a company that is looking to move into the wind market, the wind power market. And actually what they were interested in is understanding all of the operations in the UK that are coming up for 5 years or older in age, because actually they will be the ones that will be coming off their maintenance contracts after installation. So you can start off, first of all, obviously, by clustering it on a map. That's an interesting way to look at the data rather than just a list in Excel. And what these online technologies allow you to do is build clusters, but also put your own operations in there and help you think spatially, where are these things? Can we service those clients? And these pictures will look familiar to you now from the gas flaring, but it's a similar problem. And interestingly, we were invited into a strategy workshop where we had all of this set up. And just the ability to click through to some of these dashboards. I mean, I'm sure many of you have seen Power BI and Tableau and Click. Once you've got that data warehouse working and those algorithms working, it's a very powerful asset to actually have a sort of a very agile strategy type meeting. And actually, in this meeting, I think the decision was changed 3 times on the fly based on who the operators were, the owners, the age of the assets, where the relationships existed in the company. So it can become very, very dynamic in that way. So this is the, I was talking about this before, about scraping the web. So the idea of going from something like this to quickly identifying an asset and then scraping the web to find all the people connected to that asset. Again, within a few minutes, a few clicks, you've gone from a strategy, high-level discussion to a very practical business development discussion that you can link into your CRM systems and help drive the sales on the ground. It's so big, this screen, I don't know which way to look. So I have got time. I wasn't sure whether I'd have time to show you this, but given I've got a few minutes left, I will talk through this. This is, again, a completely different industry. So this is actually social housing. that we're looking at here. And what I wanted to show you is that you can build quite sophisticated predictive models that can tell you some things which are really quite surprising. So the context here, the setup, this particular social housing unit, which has about 60,000 tenants, so it's, you know, it's a larger one. They spend about £50 million a year on repairs, and a lot of that can be through wasted visits. So engineers knocking on the door and the tenant's not in to have the boiler fixed or whatever it might be. So the challenge to us was, can we make that process more efficient? So we took 10 years worth of their data, and it was a mess, because everybody's data is a mess. So that's the first thing to say to everyone: don't be embarrassed about your data. Everybody has messy data, particularly when you're trying to go back 10 years, because it just wasn't thought of in that way. So, you know, our data engineers did a bunch of work to wrangle that data and get it into a format that the data scientists could have a play. And they actually built a random forest-based predictive algorithm. And what surprised us was the accuracy of it. So we took, I think it was 6 years of the data to build the algorithm, and then we tested it on 4 years. So that's the sort of dark data that you present to the algorithm to see how accurate is it. And obviously you know the output because it's in the past, so it's an event that's happened. And I think we got to about 83% accuracy. Now what's going on here is you can put in a tenant ID, and also I should also say, it's very important, this isn't something that you would give to a housing officer and say, look, you know, go and do that. This is in a way trying to do explainable AI. So we're trying to talk the leadership team through what the model's doing and what the output is. And I think at the end of that, I'll show you, you know, how you can translate that into a business process. So here you can select a tenant's ID, so a customer ID. You can select the reason for the visit. Is it agreed with the customer or not? So not surprisingly, if you're turning up to have a discussion about rent that's not being paid, you probably wouldn't signpost that to the customer. And then what the algorithm does, it looks over the next 2 weeks and it says, when is this person most likely to be in? Mind blown. That was incredible for me. The fact that you can actually have an algorithm that would say over the next 2 weeks, you know, these red markers give an indication of when that person is likely to be in. And then, when you select one of those days, it can tell you what time of day is the best time to go and knock on that door. So in this case, it's at 2 o'clock. 83% of the time that was accurate, that had an accurate result. So how you unpick all of that, that's the complex data science piece. That's the random forest algorithm that's been guessing all of these different attempts and trying to come up with right answers in it. How you turn that into a business process, well, what we do now is we take that and, you know, a housing officer has on their CRM or their calendar all the appointments that they have to make for the month, and they have to go meet customer number 33 at 2 o'clock on this particular day. Why? Well, that's because the algorithm says you're probably most likely to catch them in at that time. So again, it just completely changes the way that people think about and do business. So that's my examples. I'll just end on this slide. Coming back to this whole idea of a net zero, I think when I first started out, so yes, I trained as a chef, but I did go back and do other things like A-levels and university degrees, and went into a career with Accenture and Boston Consulting Group. So that's my, you know, sort of corporate background, as it were. And when I started with Accenture, which was about 20 years ago now, everyone was talking about hydrogen fuel cells. And I remember that the project that I was on, which I can talk about now because it's been launched, but it was the BP Ultimate Fuels. So back then, I think Optimax had just launched, and there was this whole race to get these premium fuels out there globally. And one of the Accenture partners had made some statement about within 5 years we'll all be using hydrogen fuel cell cars. And there was so much backlash for that statement. You know, I remember that you know, we were working with BP, and they were furious with Accenture that, you know, they'd come out and made this statement. So I think about that experience compared to today. I don't think we have the option to be furious about these things anymore. The world is changing. You know, the eyes of the world are upon us, and you know, all credit to Greta Thunberg for what she's achieved at such a young age. But you know, I think that there is no going back. We need to really think about this. And I think, bringing in new ways of doing business, particularly when you think about who's going to make net zero happen, right? It's not all going to be new companies. It's going to be the old traditional companies that have all the engineering skills, all of those years of experience, the capital, the investment, the money, the know-how. That's what's going to make net zero happen. And I think that, for me, feels like a new way of doing business, and it's pretty exciting to be part of that. And I think hopefully today you've seen a few examples of how that can help along the journey. Thank you very much.
Thank you, Steve. So I'm sure there is a few questions. We have about 20 minutes for questions. So is there any questions for Steve? Yeah. Use the microphones because we are recording this.
Hi, thank you very much for your presentation. It was very exciting. How does that match with people's right of protecting their data? So, what is with regards to data protection? How does it fit?
So, are you talking about the social housing example?
Yeah, basically using data that belong to other people.
Yeah.
To target those people in a way. I'm not sure. I'm not an expert in this area.
Yeah, so I think, first of all, it is an excellent question. And whenever we start a project like that, ethics is the first thing that's discussed, both with us, with the client. You need to always have that view that it is personal data. We don't scrape that personal data, so we're not Cambridge Analytica or anything like that. This is data that the Housing Association has access to. Their tenants have signed up to share, to use that data. So it's not, so from GDPR perspective, they have given permission to use that data. But we manage it very carefully internally. So to give you an example, the reason why it was all customer number 33, we had a very small team that ingested all of the data, and then they anonymized that data before handing it to the data scientists. So I think as an organization, if you're working in this space, you need to be aware of those issues. You need to have the conversation with your client up front, and then you need to figure out, well, what are the real risks and how do you mitigate them? So I think it's definitely an important consideration.
And just to add on, awareness and management and trust around data sets, especially when they're shared across industry, across society. We're doing a lot of work on that, particularly within our use case for things like project analytics. The Open Data Institute is doing an awful lot of work around this, especially when you apply it to the individual. So I think it is a key thing. But I think the technology and the ideas of how you treat it from a governance and legal perspective is there as well. But ethics is important.
Thank you for the presentation. I really enjoyed it. What advice might you have for people who are looking at going to train to be a data analyst or scientist as their first career? So maybe people who are at school or university. And then second part of the question is, what about people who are maybe in the workforce who are thinking about retraining? What advice would you have for them?
So thank you for the question. We've got experience of both of those things. So I think advice, I feel old giving advice, but for the people starting out, be proactive. So I'll give you an example. One of our data scientists is a chap called Tim, who's doing his PhD at Edinburgh University. And Tim, I think, sent me probably about 25 emails, of which I ignored all of them, not out of malice, but just that I had another 150 that were more important. And then he started phoning me up. And he was proactive in that sense. And then I went for a coffee, and I was still scratching my head thinking, how is this going to work? It turns out he's an absolute legend. Because that proactive, that shone through in the discussions, I think for us, about having data scientists that you can put in front of clients that can think laterally, that can maybe unpick a problem in a unique way. So I think that would be my advice to anyone studying now, is be proactive. Try and find those opportunities to get, with industry, do industry projects, or even have a way of demonstrating that you should have a passion for that within the industry. And I think retraining is definitely an option. So one of our software engineers retrained. I've forgotten what she was originally, but she went and did one of these code-based transforming courses. She joined us initially as a tester, but now I think I would call her a software engineer, so she's progressing on that. So I think this whole world is changing, and people will have to reskill, they'll have to retrain. And I think there's certainly an appetite to absorb that, because it's like I said, it's us that's going to change this net zero. It's not, we're not just suddenly going to magic up all of these new skills. So.
Steve.
Hi, Steve. Thank you for the presentation. So my question is, AI is often attributed to the fourth industrial revolution, wherein a lot of jobs could be automated and there's a chance that humans can be replaced by AI. What's your thought about that, particularly on the energy sector?
I'm smiling because I hear that quite a lot, the whole Terminator, doomsday, come with me if you want to live type thing. I think we're a long way from that. I don't think humans will be replaced in the next few generations. I think what you'll find is that the nature of jobs will change, and humans will have to adapt, as we always do, to what those new jobs look like. And I think what will happen is the mundane will be taken away, and it will focus more on the higher value add. And so all of this stuff that, I had that slide up of all those different data sources, that's the headache that people have today. That's the pain. They have to wrangle with it. They spend 80% of their time just wrangling with all of that data, and it's not a particularly high value add thing. But actually, if you can use technology to take that pain away and then focus on, well, what are the insights? How do we change that? Then I think we just progress at a much faster rate.
Steve, hi. How accessible is a platform like Ocean? You talked about some of your clients and you referenced corporates quite often. Is it something that SMEs can access? How do they access it? Where does the AI, big data play in terms of the kind of service companies that the oil and gas industry has? There's tier ones, but the majority of them are tier 3, tier 4. They're small, medium-sized companies.
A very good question again. So, and actually that's one that I'm hoping that we get to work with the OGTC on. So, so for those that don't know, Brainwave actually spun out of the US intelligence community. So the original founder was in that world. And I was in St. James's, BP's headquarters, 2 weeks ago talking to Julian Gray, who's their head of innovation. And actually just before, I'd always heard that BP were doing something with Palantir, and just before I went in for the meeting, I kind of Googled it and thought, what's going on? And there was all this big press announcement about the billions of dollars that they're investing in Palantir, and I thought, oh my God, what am I going to go and have this meeting? I've got nothing to talk to him about. But then, as I went into the room and I showed him what we're doing, and he was like, well, actually, yes, we do a lot of this with Palantir. And I said, well, okay, there's probably not much more to say. Thank you for your time, and I was about to leave. But then he said, however, Palantir are very expensive. Now, I used to work at Boston Consulting Group, which was very expensive, but I think the indication I got is you can times those rates by 10, and you get somewhere close to what a Palantir consultant would charge. So, so even on that big global business scale, I think there is an opportunity for smaller companies like Brainwave to operate in parts of the business that can't afford the Palantirs. At the moment, we've been set up to work with big business. So we've been working in social housing in the mining sector. But our hope is that, through investment and over time, that technology becomes more accessible. I would say another important point to think about, though, is smaller companies, or certainly the ones that I've been speaking to, often the way they're set up is quite challenging to some technology like this, because actually trying to get business development teams working together when they are very individual-led. So in big corporates, you typically have teams of people that have, they have strategy and management meetings, whereas in the smaller companies that I've seen, it's a very individual. They've got a network of people. They've got their, they work that network. So, but ultimately, there's no reason why it's like any other technical product. It will eventually come down in price, and you can start working with the smaller companies. The thing that drives the price at the moment is the data connections. I mean, some of those subscriptions are pretty expensive, right?
Yeah, thanks for the talk. I just had a question on the satellite data. So is the collection of the flaring data, is that contingent on cloud cover, or is there infrared remote sensing that kind of bypasses that?
Yeah, so that's a good question, and yes, of course, it's susceptible to cloud cover. So that's what the algorithm does. So if you were to looking at the volumes, you wouldn't want to take a one-day image because if there was a cloud covering it, so they typically look at 7 days average or a rolling month. We work closely with the guys at the Mines, University of Colorado, who came out of NASA. So if you look at the World Bank, they have some gas flaring data on there. And our initial algorithms were based on that work, but we've taken it one step further to tie it to assets and cross-check it back with those NASA scientists to make sure that we're not missing anything. And yes, there are some inherent problems in that. But I flashed past a graph because it was boring, where I was showing the correlation in Nigeria. I don't know if you remember that one. And actually, what you saw on there, there was a very close correlation. There was a linear factor that we had to adjust for, but it's definitely there.
And the digital age is seen as the fourth industrial revolution, as somebody said. In comparison to the other industrial revolutions we've had, what would you say the sort of comparative emissions might be from digital AI machine learning? Do you have any comment on that?
Ooh, that's a good question. It's probably going to be focused around the ethics of data. I mean, we touched on it a little bit. I think the more that technology enables you to scratch beneath the surface and connect these things and draw out conclusions, I think the emissions scandal in 20 years, 30 years' time will probably be around that protection of personal data. And I mean, we're in Europe, so we've got some of the world's best data protection laws. Well, at least we're in Europe for now. So yeah, I mean, I don't know the answer, but I think that's, and I think there's a few consultancies in the room that I was speaking to before that work in this field, and you do think about that all the time. What are the unintended consequences of the work that you do? And I think it's a tightrope, because in some respects you could get to the point where you just don't do anything. So if I think back to the social housing, the initial interaction, it was about 6 to 8 weeks to just get over that reticence, because this fear of what could go wrong, it could, and not just in data, but you could have that philosophy on a lot of things and end up doing nothing. So, so I think we have to be cautious, we have to be careful, we have to develop those protections, but I think it's probably going to be something around that. Did I understand the question right? Or was I misinterpreting?
It was more on the power required to to run these very high-powered computing. The more and more we use it, and the more we use AI, which handles lots of data, lots of computation, is going to need a lot of power to do that. So that was around my question on the power required to make these efficiencies may have unintended consequences in the emissions, and what some comment on was around that. We have our industrial revolution and our sort of mechanization of things, which has an emissions that we're starting now to understand the consequences of. What do you think the unintended consequences of the cloud computing age might be? That was.
So I should become a politician because I answered a completely different question. No, I think it's a good question. I mean, I think, I guess one benefit that cloud has over distributed is that it is centralized. So, when things are centralized, they're bigger, you can put in bigger solutions. So I don't know if you'll have data centers that are purely fed from wind farms or solar farms, or probably a mix of both. But, maybe that's an answer, but, I haven't given it much thought.
Some other questions? Anyone who hasn't asked a question?
Thank you for your presentation. It was really interesting. And just along the line of the last questions, how do you see we can manage the volume of data which is produced and will be produced even more in the next future?
So I think, technology will help you. I think that it's not this idea that, there's this tsunami of data. I mean, there is a tsunami of data, but there's also all these new technologies and, data science approaches that are geared up to deliver that. I think the nature, what will change is the nature of business, of people's job titles. So, I did mathematics at university now, which wasn't very sexy at all as a mathematician. Today they're called data scientists, which actually was voted by Forbes as the sexiest job title in the world. So I am technically a data scientist from 20 years ago. But so I think you'll see universities investing in new courses. So the skill set will change, but people will learn those skills, and technology will continue to support that effort. So I don't think we should be afraid of it. I think we should embrace it and figure out. I think the biggest thing for us that we see is humans don't like change. And I used to see this all the time at Accenture. Whenever we did a big implementation of any software, back then it was SAP. We plugged SAP into anything that moved. And the change effort that's required to get people to interact with that software is huge. It's phenomenal. And back then that's okay because these programs were like 4-year implementation programs. The way that technology works today in Agile, you can have things up and running in 2 months, 3 months, and getting people to adapt to that pace of change is really difficult. So I think that's. Yeah.
So, anyone else got a question they'd like to ask? Because I was just going to make a comment on that. I think data quantity is increasing phenomenally. The power of tools like this, though, it allows you to ask the right questions, which enables you to essentially moderate the data and cut down the data that you're collecting. So in other words, that implies that you can throw away data, but it's not necessarily that. It's throwing away duplications of data. So for instance, starting with the mining example there's 57,000 mines in the world. It started off with an understanding that there was 400,000, something like that. Yeah. So that's a significant decrease in data that was kept. So you can, using tools like that, so we can focus and just taking our ability to look at data and work with data. That's what the power of this gives us, is the ability to work and use data, not just figure out how to use it and clean it up, muck around with it, find stuff, and make decisions based on data rather than gut feel or basically small data sets that are not inclusive or not as big as they could be. So that's the power, and I think, but there will be a phenomenal increase in the amount of data. Technology become the need for data centers. You see data centers starting to be cooled by seawater and all these things because it's actually the cooling that's the biggest cost usually. And I think Bitcoin, uses the same amount of energy as Iceland or something bizarre like that. So there is a major challenge around data will increase. There's some huge ethics, and then the energy required for supporting massive data centers. It's going to be there. And it's going to be a challenge for us and for society. So we do have a few more minutes. So if there's any other questions that people thought about, yes.
So yeah, we're considering cleaning up our data and using it more effectively, and we just had a meeting actually about it. And when we don't use agile working, and the comment was, well, it'll take us time. We've got to get it right. So give it a whole year, and then in 2021 we'll implement it. Is agile working key to doing these things efficiently? Do you get a better product by doing it slowly and
My honest answer is agile all the way. So the beauty of agile is it's for those. I hope I'm not teaching all to suck eggs, but it's focused on short sprints that have very specific user requirements. So as opposed to waterfall, where it's a long, 3-year program and you get something at the end which is probably not what people thought it was. So what I like about agile is it focuses the mind. It focuses our minds as developers and software engineers. And it focuses the client's mind in terms of, okay, well, what do we really want from this? How is this going to help our business? Now, the other benefit of Agile, particularly if it's new to a company or an industry or an industry as a whole, is it brings people along with you. right? So if I think about when we had our first big customer, we did Agile, and they had a product live in 6 weeks. It was very basic. It was nothing like you're seeing there. But people get excited by that. Oh, I can see that. They can see the vision. They can see where it's going. And then they say, oh, can you make it do this? Could you add this in? What about if we put this source in? And we've got all these Bloomberg terminals everywhere that nobody uses. Well, let's actually put... So it brings people along. It gets them excited. And that's how innovation happens as well, I think, because new ideas come. And so for me, Agile all the way. And I've experienced both, because at Accenture, it was very waterfall driven. And now I think the new world is here, and it's here to stay.
Yep. Last question.
Question and observation. I work on a number of connected worker programs, and one of the things that I'm seeing is we're starting to collect data that we could never collect before. So there's new data starting to come along. And that's why I believe Agile is extremely important, because you'll be able to learn as this new data comes along, and be able to identify the actions and the insights from that to then move things forward again. Because if you don't do that, with waterfall and so on, it takes so long to be able to get justification for what you've done, whereas Agile actually delivers that much quicker, especially with the new data that's coming through. Right. So, like I said, it was just an observation.
Thank you.
Thank you, Kevin. Okay, so we've run out of time. So I'd like to thank you all for coming. I'd like to thank Steve. So if we have a big round of applause for Steve again. Thank you.